Take it away, Teamer.
Hello, everyone, and welcome to the Audio Programmer Virtual Meetup, November 2021 edition. Thank you all so much for tuning in. It's great to be here again. My name is Timur. I am your host tonight together with Josh. Hi, Josh. How are you doing?
I'm great. How's it going?
Doing pretty well. Thank you.
Cool. So every second Tuesday, we have the Audio Programmer Meetup, and we're very privileged to have some awesome guests with us every month. And this month is no exception. So we have Landon Viator, who is coming to us from Houston with Audiofile engineering. How's it going, Landon?
Going great. Thanks for having me.
Great. And we have Bobby and Ralph from the ADC 21 team, the Audio Developer Conference, in the house today. How's it going?
Bobby?
Good. Thanks for having us. Appreciate it. Yeah.
Thank you. This is fun.
Great. So before we get started, just want to give a big thanks to our sponsors. So we have JUCE, Sonnox, and Focusrite, who are supporting the Audio Programmer Meetup. And we would like to give a big special thanks to them for supporting us. And we also wanted to tell you that we're always looking for new people to present for the Audio Programming Meetup. And you'll be able to do that on the Audio Programmer website via theaudioprogrammer.com/submit. And also join our Discord community, where we have nearly 7,000 audio developers from all around the world who are talking about all things audio development. And you can join us on the audioprogrammer.com/community. And with that, I will pass it back over to Teamer to make any other announcements and present our first speaker.
So yeah, I guess we're going to talk about the Audio Developer Conference a little bit later. That's the big thing that's going to happen next week. For now, I think we want to introduce our first speaker. Before I do that, the people who regularly tune in will know this. If you have questions to our speakers, please ask them in the YouTube live chat, and please prefix them with the word question in all capitals so that it's easier for us to spot that there's a question there. And then we're going to ask the speakers that question here live on air. And with that being said, I'd like to introduce the first speaker of the evening, Landon Viator, who is a software developer with Audiofile engineering. And today he's going to be presenting prototyping distortion effects in MaxMSP for JUCE.
All right, cool. Thanks. Well, thanks for having me. This is exciting. It's a great opportunity. Okay, so I have a little slideshow put together. So the whole idea of this presentation is prototyping in Max, because it's a little easier to prototype in JUCE and you can get a lot done much faster. So what is MaxMSP? Well, it can kind of be considered a DAW.
Landon, before you start, you just want to share your screen again there, buddy.
Oh, yeah. That would be helpful, wouldn't it? Is that good?
Yep, we got you now.
Awesome, cool. So what is MaxMSP? Well, it can be thought of as a DAW, not in the traditional sense, you know, like Logic and Pro Tools and Studio One are a kind of editor-based arranged view DAW that has like a linear view. And Max has this kind of view. It's just a canvas. But it is a digital audio workstation because you can do DSP in it, and it has a visual audio programming language associated with it. So it gives the user the ability to perform high and low level audio operations, where high level would be kind of abstracted away from the kind of nuts and bolts. So I have an example here with the JUCE decibels to gain function, where all you have to do is input the decibel value and it'll output the gain. And then low level would be doing the actual math. So I assume this is the same function that they're using. You're raising 10 to the drive divided by 20, or the input divided by 20. So that would be low level, kind of like the nuts and bolts code of it. So in the Max environment, you can patch together audio objects that are pre-made, C++, DSP objects, GUI objects, non-audio objects, all kinds of objects that represent DSP methods in a format that kind of feels like analog mixing racks and module synthesizers, where you can patch things together and create sounds. So there are other options for prototyping outside of JUCE with audio. So there's MATLAB, of course, and the free version of it, which is called Octave. And it's more of a programming language, like a regular programming language, than MaxMSP is. So the thing that makes Max the kind of easier choice to me is that it's a visual patching. So it has like a real world analogy, and it's intuitive even for people who have never used it before, because you're just kind of patching together audio objects, kind of like you would patch together synths. So it abstracts all of those complex audio operations into high level objects. And it also has low level objects too. There are code box objects, things that you can actually write code in, which is really helpful if if you have that knowledge and you want to use it. It's super easy. It's plug and play. DAW users coming from Logic or Pro Tools will find some aspects of it similar to their software in a lot of ways. Some ways it's obviously going to be different. Like I said, this view obviously doesn't look like a regular DAW. It's kind of like a canvas. So, but once you start working with audio, it kind of makes sense. The documentation included is amazing for Max. It's actually built into the app, and you can actually access the documentation for each object by just clicking on it. And that documentation is also online at Cycling 74's website, the owners of Max. As far as online tutorials, there are an endless amount of tutorials compared to JUCE. Okay, cool. So I'll take you through a little demo of how to use Max for the people who've never seen it before and never used it before. So making objects is pretty easy. At the top toolbar, there are some included objects. So like, for example, here's a toggle box. You can grab some of the Ableton Live objects right here that were made with this language. And then you can also type in and start typing the name of an object that you know exists. Like, so I'll take the sine wave oscillator, which is called cycle, and it'll autocomplete. Just hit enter and boom, you have a cycle object. So that's how easy it is to create objects. There are some at the top here that are kind of easy to grab. So you can grab a gain slider, a text box, that kind of stuff. And then there's a bunch of objects that aren't in this toolbox that you can just kind of type in if you know what they are. And then you can search online for what objects are in Max. So data signal flow. So to connect these objects to each other, you just go to the inputs and outputs of the object, which are called inlets and outlets. And you can hover over it and see a little tooltip and see what it does. So basically, most of the time, you can just take the outlet, click and drag, and boom, plug it into the inlet. And then I'm going to make a number box. It'll be easier to show you. I'm going to hit F for float, and it'll make a float box. And if I take this dial right here, boom, I connected it. I can lock the patcher and interact with it. And I've got the connection and it works. It's sending 0 to 127 to this number box, which is pretty handy. I can do the same thing with this toggle box, lock it. It's sending 0 and 1. So it's basically a bool, right? It's a toggle. So that's how simple it is to connect objects to each other. And then you'll see that if I grab out of the cycle object, this is an audio object, and you can see that the patch cable looks different. So that means that it's an audio signal coming through, whereas the regular gray cables are just sending values, floats, integers, just control values like that. So for audio, you have to connect audio objects to other audio objects. So I can actually connect it to this gain, and that'll work. So unlocked and locked. So whenever you're unlocked, you can see the dots of the canvas, and you can move objects around, and you can grab patch cables. And when you lock it with Command E, you'll see that the dots disappear, and you can actually interact with the objects the way they're supposed to be. You can click on them and stuff. So that's all unlocking and locking really does, is gives you the ability to actually it's almost kind of like pressing build, like you get to test it, And then we talked about the types of objects. You basically have audio objects and non-audio objects. The audio objects have a tilde in front of the name, and they have a yellow and black patch cable by default. You can change these colors, but by default, that's what it'll be. And then the gray patch cables are the non-audio objects. Lastly, I'll show you how to see the documentation. I'm going to unlock it. If you hold down Option and you click on an object, it'll bring up a small max patch that actually serves as the documentation. You can see notes about adding arguments to the object. It'll usually have some kind of prototype that you can actually use. So this is a good time to test. Can you hear the oscillator?
We can indeed.
Awesome. So you can see that the documentation actually gives you a test that's easy to understand and actually works. Whereas, you know, if you go to the JUCE documentation, sometimes you'll look at the explanation and it doesn't actually, you have to kind of have a lot of C++ knowledge already to get it to work. But the Max documentation is super easy to understand, and it's already set up and it already works for you. And there are actually usually some extra tabs for extra functionality of the object. So that's how the documentation can be accessed, and it's very helpful. It's amazing. I love it. Okay, cool. So the whole idea of this presentation is how do we make distortion? And I think the first thing we need to talk about is what really is distortion, because there's people describe distortion in all kinds of different ways. They'll say distortion, overdrive, clipping, saturation, you know, and they're really all kind of talking about a similar idea, which is just the deviation in the shape of the waveform from input to output. So if you have some kind of DSP process or transfer function, you're going to change the way the audio looks from the input to the output. And that's technically all distortion really is. And to prototype and make distortion, there's actually a bunch of different ways that we can accomplish this. So we could do this with trig functions such as, you know, tan, atan, even sine and cosine. You can use polynomials, which are in this kind of form, and I actually have a tab pulled up. Polynomials. So basically you'll have like a number multiplied by x raised to some kind of exponent, you know, plus or minus another term. And that's basically all a polynomial is. It just means multiple terms. And what you would do, x would represent the signal. So you would just, if you were writing it out in C++ and you're writing the equation, you would just kind of input your signal as x. And I'll do that in Max. Okay. And then you can do direct wave shaping is what I call it. I don't know if there's a proper word for it, but it would be kind of like if you were in the process block of your JUCE project and you said like, you know, if sample is greater than 0.25, do something, and you're changing the wave only at that top like 75% of the positive form. That's what I don't know if there's a word for it, but that's what I call direct wave shaping, where you're just kind of doing math with conditionals or if statements or something to the waveform. And then something that's really helpful is adding a multiplier to your input, either before or after it goes into one of these functions. If you do it before, it'll give you more distortion and it'll give you basically a drive parameter. And that's kind of an analogy to how guitar amps work. I mean, you're sending your guitar into the amp and you'll have a certain amount of distortion by default. And if you increase the guitar's volume going into the amp, you'll get more drive and distortion. So yeah, let me just go over to Max and I'll start showing you a couple of things. So I'm going to get rid of all of this. And I am going to make a output device. It's called the Easy DAC. That's what I use. I'm going to make a gain slider so that I don't blow your ears out. So here's a simple gain slider. I can connect it to the output in both channels. And you can see the gain slider is all the way down, so you shouldn't hear anything. And then I'm going to make a sine wave again. I'm going to do 220 hertz, so it's not so annoying. And I just want to make sure you can actually hear this. If I turn audio on by clicking the button. Can you hear that?
Yes, it's a little bit low, but we can hear it.
Okay, yeah. So let me bring that down. So I'm going to show you how to use the atan function, and then I'll do a polynomial just to kind of show you. One popular clipping algorithm that I got from Eric Tarr's book, Hack Audio, is the soft clipping algorithm, which this might be a little hard to see, but I'm going to zoom in. It's just a little comment object. So the saw clipping algorithm is basically 2 divided by pi times the atan of your input or your signal multiplied by your drive. So that's that multiplier I was talking about. So it's very easy to build this in Max and very quick, and you'll see how much faster it is to do this in Max than it is in JUCE. Because imagine in JUCE, if you want to have some GUI objects to test with, and you're going to want to, make your audio processor state tree attachments and stuff, and it's going to take you a little while to set all that up, unless you have your own little framework set up. But you can see how easy it is to just attach objects and create GUI objects in Max and connect them to stuff. So let's just go ahead and start. I'm going to start top down, and I'm just going to kind of build this equation with Max. So we need 2 divided by pi. So what I'm going to do is I'm going to make a signal, which is basically just a number at the audio rate. So I'm going to, since we're doing audio, everything's going to be audio. So I'm going to make a signal of 2. And I'm actually going to divide it. So like I said, everything with a tilde in front of it means audio. So divide it by, I'm not sure if there's actually a pi object. So I'm just going to do 3.14. So cool, we've got that. We've got 2 divided by pi, and then we're going to need to multiply that. So 2 divided by pi right here, and then multiplied by, we're going to say the atan. Oh.
Oh, let's just keep going and see where we go.
But can you still hear me?
Yeah.
You might have to select loopback as the output from Max, or do you have Max open as a separate app, or is it like running within Logic? So.
I can still hear everything fine. So.
Oh, okay.
Yeah. Say something. Oh, okay.
Yeah.
This is the trial. This is the trial mode. Okay. No. Man.
Josh, you're muted now. Oh, you're back.
Yeah. Sorry. Yeah, just trying to figure out what to do here. So Landon, let's just continue without the sound and do the explanations, and yeah, we can come back to this. If you're talking, we can't hear you, Landon. One second, just experiencing some technical difficulties. Apologies for this.
Cool. Can you hear me now?
Yep,
Yes.
we're all good. Yeah.
Okay. It's actually okay because I'm going to use a oscilloscope, and we can look at it that way. We don't even have to listen to it.
Great.
Yeah. So I've got, let's see. So we've got 2 divided by pi, and then we're going to multiply it. And you can see that I'm thinking top down, and we're going to multiply it by atan right here. And then all we have to do is send our input multiplied by some kind of multiplier into the atan. So what I'm going to do is make a multiplication right here. Oh, wait, we're going to do this. And I'm just going to make an integer. Let's see. I'm going to make a scope object. And when you're on an object, if you want to access the attributes for it, you can hit Command I, and the right toolbar will pop up, and I'm going to move this out the way, and I'm going to select automatic mode for the scope object, which is really handy. That. And I should, there we go. So we've got our waveform for the cycle. Cool. And now our input times drive is right here. So if I start increasing this, we should see some distortion or wave shaping. Oh yeah, look at that. It's squaring. Awesome. So what we're doing, if I go over to, I can show you what this equation is actually doing on a graph. If we go over to Desmos and I do 2 divided by 3.14, and I multiply it by the arctan of X, you can see the equation, or you can see the line that forms. And basically what we're doing is we're applying this line to the sine wave, and we're driving it harder with a multiplier. So if I just go in here and I just multiply it by 10, you can see now it's much more square, and it's kind of getting more constrained. And that's basically all we're doing to the waveform in Max. So it's really easy to test. You don't even have to have a known equation that works. You can just kind of start multiplying these objects by each other and see if it does anything cool to your waveform. So there's your drive function. And then we can do the same thing with a polynomial. And I'll just take the polynomial that was on that Wikipedia page, which is 3x squared. So squaring something in Max is pretty simple. You just multiply it by itself, and X is our signal, so we can multiply it by itself. And then I'll make another multiplication and multiply it by 3. And then what's next? Minus 5 times X, minus tilde right here. 5 times X, so I'm going to take this multiplication, change it to 5 times X. And then lastly, plus 4. I found that adding, if it's just a plus or minus of a whole number, it doesn't really do much for the waveform except, you know, shift it over, but we'll do it just for fun. Plus 4. And then we can see if it does anything interesting. Oh yeah, look at that. That looks like not a sine wave. That's pretty cool. But you can see the top range is at 12 and the bottom range is at 1.9. So you can add some multiplication and some addition to shift it over back to be around -1 to 1 if you wanted to. And then in the spirit of prototyping, since it's so easy in Max, I'm going to take a tan and I'm just going to plop it in. Like I'm going to say the atan of this minus the atan of that. So let's see. I'll put it in here. Okay, we changed the shape again, which is awesome. Cool. Oh, wow, that's quite different. So you can see how fast and easy it is to prototype in Max, even if you're not really sure what you're going to be trying. And if you're doing this in a JUCE project, you know, you're probably going to be, you know, hitting build, trying a couple of things, opening it in your DAW, listening to it through an oscilloscope, checking it out, reopening the project, do it again. But this is much faster. And then I can do this. I can start adding my own multipliers instead of 3 and 5. I can just start doing my own. Yeah, look at that. We're getting something. And then since I know that that's driving it and making a weird shape, I can know that that can be my drive parameter. And in my JUCE project, I can send drive to these two terms right here. So instead of 3 and 5, I can make this drive. So it'd be like drive X squared minus drive X plus 4. And that's kind of the real spirit of prototyping, in my opinion. Like you can't really do anything wrong. Like, sure, you might do something that won't sound good, but you know, what does it matter? I mean, if you find something interesting, you'll know. And it's a lot more fun to do it this way. So yeah, that's kind of like a brief, very quick overview of prototyping in Max. So I'm going to take the soft clipper and, oh, I forgot to open Producer. Distortion Meetup. I'm going to open that in Xcode. And of course, it's going to take forever.
As it always does. Thank you so much for this, Landon. This is really helpful for people that are just getting started.
Oh, I'm glad. I'm glad it's not just me rambling on. I'm glad other people find value in it.
Absolutely.
I'm going to delete the code because that's what we're going to do together. And I'm going to kind of show you what we're working with basically. So I'm going to do the soft clipper. I'm going to build it in standalone just so that you can see what the GUI looks like, just so that we know what parameters we have. That first build when you open Xcode is always the longest, and then after that, it's quick. And you'll notice that in my process block, oh, okay, finished building. Let's see. Awesome. Here's my amazing GUI. We've got an input, a drive, a mix, and an output. And the input is going to be driving, or it's going to be adding a multiplier to the input. And the output is going to be adding a multiplier to the complete output so that it's a final kind of trim, changing the volume of everything. And then we have our drive and mix. So the mix is just going to be the difference between the dry and wet channel, or the dry and wet signal. So that's what we're working with for parameters. I already have all the listeners and attachments set up and stuff, so we don't have to worry about that. So my process block right here, I have it set up with the typical sample channel for loop, but I'm doing it based off of the audio block instead of the buffer. And that's just because I've been doing that recently, because whenever you abstract it out to a class, you'll probably have like a process. So it'll be called like softclip.cpp, you know, and then I'll have like a process block function where I pass it the audio block, just in case I'm doing, or I'm using other JUCE DSP objects that I'm using the audio block for. It just makes it consistent. You know, I don't know if it's like the best way to do it, but it makes it consistent so that my process block always has like, you know, filter.process, softclip.process, trim.process, whatever. And then I'm just passing it the audio block and it looks nice and clean. So yeah, that's how I'm doing the DSP in this example. I'm not abstracting it out to a class. I'm just going to do it directly right here. So the first thing I'm going to want is, even without having to look at Max, we need some kind of input variable. So I'm going to say auto, actually, I'm going to say const auto input is going to be equal to, I have data right there for the channel pointer. So I'm going to say data sample, and then I'm going to multiply it by the input variable, which I have already set up in the header. I've got an input DB that's connected to the dial already. So I'm actually going to multiply that, but it's in DB. So I'm going to call that nice JUCE decibels function, so I don't have to use PAL 10 blah blah blah. What is it, decibels to gain? And then I'm going to pass it input DB, which is down here. So just with that, all I'm doing is being able to multiply the input and, you know, make the input louder, which will drive it harder. And then I'm going to say const, let's see, I'm going to call this soft clip, I think, which is equal to 2 divided by pi. Now, I don't know if this is even really a thing anymore, but, you know, I've always heard that you're not supposed to do division in your code when you don't have to. And what I did was I went in the header and I just went ahead and defined what 2 divided by pi was with this math constant pi and 2 divided by it. And I just called it pi divisor. So that's just a quick and simple little way to do that in prototype with. So I'm going to say, oh, we have,
that needs to be const auto, by the way, soft clip.
Oh yes, const auto soft clip. If you remember, the soft clip algorithm was that pi divisor that I made, and that was multiplied by the atan. So we call stood, there's an atan, I'm going to do the ATAN F1 right here for the float. So this is going to be the input times your drive. So this is input. We already have that right here that we made above. And then drive is also in dB. So we're going to have to use the same conversion. Drive dB. Cool. So that's the ATAN. We've got 2 divided by pi, which is stuck in this variable, times the ATAN of input times drive. Yep, that looks right. And then we're going to blend it. And this is something I just picked up recently. A nice little blend algorithm. I think also from Eric Tarr's book, Hack Audio. So we're going to blend it. So we want the mix. When the mix is 0, we want only the dry input. And when the mix is 100, we want only the like soft clip. So I'm going to say, let's see, think input times, and then you could do this trick right here. 1 minus mix. My mix is the dial goes from 0 to 100, but I have it scaled right here. I have it scaled in the parameter change to divide by 100 so that it's between 0 and 1. Cool. So I think that's that plus soft clip times mix. So let's take a look at this and make sure it's correct. So we're basically, we're adding the input and the soft clip together, but then we're changing that with the mix. So when the mix is 0, that means that this equates to 1, and we're multiplying it by input. So input times 1. Yeah, that sounds right. And then we're adding soft clip times 0 when it's at 0. So yeah, then we'll only have the input. And when mix is 1, 1 minus 1 is 0, multiplied by the input is 0, but then soft clip times 1. Yeah, that's correct. That sounds correct. So that'll give you your mix between dry and wet. And then whenever these are at 0.5, so halfway, it'll be half of the input added with half of the soft clip. So that'll blend it. Yep, that sounds right. And then we're going to add the output, right? So we're going to multiply that. Let's see. Actually, I'm going to make it not constant. So we're going to say blend times equals the same conversion right here. And that's going to be, I forgot what I called it. Did I call it output? Yeah, output dB. And I think that's it. We just have to send it to the block, right? So we'll say data sample. We have to replace what's in there with what we want. And that's equal to blend. And I think that's it. Let's see, we've got our input. We've got our input, the actual input coming from the block multiplied by our input variable. We made a soft clip algorithm times ATAN of input times drive. We're blending it with the mix. We are multiplying the entire mix by our output gain, and then we're sending that to the block. And I think that's it. Yep, that's it. That's about it. Let's see. I could show you what it sounds like, but I'll have to mess with the audio. It might not work because of that loop back trial thing. Let's see. Should I just go ahead and switch outputs and see if it works?
Let's see. And if it doesn't, if it doesn't work, then what I could do is I could get samples from you afterwards, and we can put those back in when we edit it back.
Okay, sounds good. Let me just build it real quick and see if it works. And you can see let's see, get that out of the way. Can I get this out of the way? Yeah. Oh, Logic was already open. Let me close it. Yeah. Okay, so you can see I attached it to Logic by going into product scheme, edit scheme. And I have the executable set to Logic so that when you build it in debug, it actually opens in Logic. And that way, whenever you hit an assert or something like that, it'll pause and show you where it is, which I didn't know existed for the longest time. And I think that's very helpful for people starting out. So now whenever I hit play, it'll open in Logic. Okay, I'll open up my tester. Okay, let's see. I'm going to change the output real quick. Back to my interface. And let's see, zoom. Volt 176. Let's just see if it works. Are y'all hearing that?
No, unfortunately not.
No. Okay. Yeah. It's probably not worth the time to try and figure this out. But it's basically just, it's a basic overdrive kind of soft clipping algorithm. This is what the I don't remember if I showed you, this is what the interface looks like. And yeah, that's basically, you can basically do the same thing with the polynomial. And then you can just, let's see if I have it in Max. Yeah. So I have, so 3x squared minus 5x. So it would be, x would be the input. So you would just basically write this out in your project in the process block, and then just replace x with input. And then you can replace 3 and 5 with your drive, and that would probably do the same thing, and you'll get a different shape. And then you can also, I'll show you this in Max real quick. If you filter after the distortion, you can change the shape a lot. So let me go back to doing the soft clip. I'm just gonna do this real quick, the ATAN. I'm gonna leave out the pi. Let's see, times tilde. That. Let me see. Make sure it's set to 20. Send it to the scope. We can see it's very square and very cool looking, but we can actually filter it. So I'm gonna make a state variable filter in Max. I'm just gonna do this arbitrarily. Like I'm just gonna put a cutoff of like 1,000. And the cool thing about this object is you can send out the low pass output, the high pass, the band pass, and the notch. So you can try this very quickly, and you can already see that we have a really interesting shape right here that kind of looks more analog and realistic. And we can do the high pass, see what that looks like. Oh, I don't know about that. We got band pass. That's interesting. That's going to sound ridiculous. And then notch. Notch is usually the coolest one. This is very guitar amp distortion looking to me after taking some impulse responses of my amp and looking at them. This is very analog looking to me. So you can just use some filtering and change the shape of the distortion and make it way more pleasing and realistic. So you can figure out what filtering does the coolest thing to your audio, and then you can just remake that filter with like the included JUCE filters, and it'd be very simple. So yeah, use some filtering, pretty cool. And that's very quick, as you can see. And I think that's about it. That's kind of like my process of prototyping and then remaking it in JUCE. It's way faster than trying to code all of this and then see what it sounds like after building it, and then, you know, coming back, making a change, going back to Logic, building it. You know, it's much faster. And it's easier to get into than MATLAB because you can just patch things together, and it makes it's more intuitive, especially for musicians.
Yeah, thanks, Landon, for this great overview. I think it's a really, really good thing to have in someone's toolbox, you know, when building and prototyping stuff like this.
Yeah, thanks.
So we do have a question on the chat from Yas, who's asking, Landon, do you use data buffer in Gen to make a LUT using peak and poke for your distortions? I have been doing it for a while, and process is way cheaper.
I have used Gen. I do use Gen a lot because you can use the code box. I haven't used the buffer object that they're talking about. I don't think I've ever used it. But what I typically do is if you go into Max and I make a Gen object, Gen tilde, you can double click and open it. And then you get another patcher, and it's basically the Gen patcher. You get inputs and outputs, and you can actually make a code box object. and you can just write basic C code right here. And I have done this a lot so that I can kind of like, I can do like an overview in objects, and then I can make a code box and write the code that kind of mirrors that same like assortment of objects, which is pretty handy.
Can you share your screen again,
yeah,
just to show people what you mean?
So actually, let me redo that. So you can type gen and you can get the one that has the tilde in front of it, and you can double click it and you'll get another patcher. And this is the gen environment. I can get rid of that. You'll have an input and an output that you can use. And what I typically do is I will make a code box, and I'll just say something like in1, which would be the inlet, is equal to an input variable. And then I'll send my audio into that inlet right here. And then I'll write whatever equation I want in here, and then just check out the output, which would be kind of closer to what you're doing in your JUCE project, but it's still way faster than, you know, having to press build, stuff like that. And so if you're already comfortable with coding, you can use the gen patcher. And I think you can export the code from the gen patcher, and it'll give it to you in some files. I've never utilized that, but I know you can do it, and I know people have done it, so that's an option.
All right, cool. So another thing which was mentioned, I think you mentioned it yourself during the talk, and then there was a comment on the chat about it as well. But you mentioned division. So somebody posted on the chat, the division is optimized the way if you divide by a constant and replace it by multiplication. It's not quite right, actually, because if you do floating point division and floating point multiplication by like the inverse, that's not exactly the same operation because of the way floating point works. Yeah. So the optimizer is not going to replace one by the other unless you specify F fast math, which is this option where basically you don't do precise floating point math anymore, but then you have other problems. So you probably don't want to do that. But if you don't do fast math, then the optimizer is not allowed to replace division by multiplication because it's not exactly the same operation, right? So then you would have to actually calculate the inverse yourself and then multiply by that. And if that's all, if you do all that like as compile time constants, then I guess that's the most efficient way to do this.
Yeah.
So yeah, you probably should avoid divisions if you can. That still applies as a general advice.
Yeah, cool.
You can check that on like Godbolt Compiler Explorer, like what the actual like, you know, output is, the instructions like with fast math, without, and stuff like that.
Yeah, like you can go through the assembler instructions and see what's happening.
Yeah, exactly. Yeah. And if you will see that by default, even if you do O3, like the division is still in there as an instruction, unless you do fast math.
Yeah. Cool. Well, that's good to know.
All right. I don't think we actually have any more questions on the chat.
I've got some questions.
Oh, cool. Okay. Josh, go ahead.
Yeah. So I know that a lot of other people who are just getting started must be wondering where you've learned about all this. And I was wondering if you could talk a little bit about the resources that you've used in the past to actually start learning how to do this. So you mentioned the great book Hack Audio by Eric Tarr. And what are some other resources that you use as well?
So another book that I use is Designing Sound by Andy Farnell, which is very similar to Hack Audio in that it takes you through a bunch of DSP processes, but it does it through the lens of Pure Data, which is a free version of Max. It's almost exactly the same. It looks a lot more low res, but the objects are almost exactly the same names. And that's what he does. And it's kind of more in the realm of designing sound. So I use that to, when I was working on a video game, to design like a fire crackle sound. So he basically in the book has a huge repository of different sound design patches in Pure Data, and he talks about the DSP behind it. Also, just going to Google Scholar and trying to search for, whatever DSP idea that you're working on or trying to work on, you might get lucky and find a paper that has the actual code version of the equations, because sometimes working through the math, especially if you're starting out, is very difficult if you're not already doing that. And I've learned a lot just in the Discord channel for the audio programmer in terms of distilling down math to whatever the code would be. So that's been a great help too. Everybody in the Discord seems to be very helpful and eager to help other people. So that's awesome. But those are the two books I use a lot. I've read through them multiple times.
Amazing. And what type of math? So another common question that people ask is, what type of math would you recommend that people study? Like if they were going through university or they wanted to check out a course online that was focused around DSP, what would you recommend for math courses to get started?
I think I would say the course that I wish I would have taken, which is, you know, some kind of pre-calculus or differential calculus. You know, a lot of what you're doing is just linear algebra and kind of just getting yourself comfortable with writing equations, like, you know, multiplying certain things to get certain effects. And, you know, oh, if I'm multiplying this and I subtract it by a certain amount, that'll even it out. Kind of like the blend algorithm was very, very simple algebra. And, you know, most people are pretty good at algebra, but it kind of takes some practice to be able to kind of like, you know, like conceptualize those things. And as far as other DSP processes, I would say that I wish I had more experience in differential calculus for like, you know, time-based effects, because a lot of times you'll see either an oscillator or a time-based effect code that has like, you know, dt over dy, all that stuff that I wish I'd had more experience in. So that would be helpful.
Great. And you've created a couple plugins now, and I think if people wanted to get in touch with you or wanted to find out more about you, where would they be able to find out about you or get in touch with you?
So I have a website, landonviator.com. And I also have a Patreon, Viator DSP. So I have like 10 plugins on my Patreon that I routinely update the GUI and then update the DSP whenever I learn more things. So those are basically the two sources.
What an awesome resource. Thank you so much for your contribution and for giving this talk. I think it's been very informative for a lot of people.
Well, thanks. I appreciate the opportunity.
Good stuff. Great. All right. So I think that's it for this one. And then Timur, would you like to introduce the next speakers?
Yeah, today we have Bobby Lombardi and Ralph Richburg from the ADC team. And I think maybe you want to just introduce yourselves.
Thank you, Timur. Yeah, sure. Sounds good. Okay. Hi, I'm Bobby. So this year, I am working on Audio Developer Conference like last year. Last year, we were all online. We did not do the in-person last year. But this year, I'm functioning as the ADC chair, and we are super excited to show you some stuff. I work for Pace Anti-Piracy, and I will pass the mic to Ralph to let him introduce himself.
I'm Ralph. I'm also working with ADC, and I'm also with Pace Anti-Piracy. My role with the ADC is design and visual director. So what we're going to show you today is our virtual venue. It's called Gather, and so we'll go ahead and show that. But you know, this conference this year will be a hybrid conference. There'll be a live portion in London, and that occurs next week. Right, November 15th and 16th.
Yes, Monday, Tuesday, yes.
Yes, and there'll be the virtual as well. So
yeah,
you should want me to go ahead and start sharing?
Yeah, no, I wanted to go ahead and maybe I would imagine many of your viewers already know this, but Timur and Josh are also part of the ADC team. I just wanted to give a big shout out to both of them. Timur is our program chair this year, as last year as well. And I have to say, the program is one of the most impressive programs for a conference. It's just lovely. If you haven't seen it, you know, audio.dev, check out the schedule. And it's just full of just the most amazing talks. And they range from beginner level to intermediate, advanced, some nice panels. I mean, Timur, you did a knockout job this year. It's wonderful.
Thank you very much. But actually, you know, it's mostly the people who submitted these talks and people who voted on them, which is quite a lot of people. Actually, one thing I want to mention quickly about this, because it's really cool. We have, as you already mentioned, we have a hybrid conference, which means you can either participate online in the platform that we're going to see in a minute or on site in London. But the cool thing is that no matter whether the speaker is online or on site, or whether you're online or on site, everyone gets to see all the talks, because the on-site talks are going to be streamed online and the online talks are going to be streamed into the venue. So just wanted to mention that because I think it's really cool. I have never been to a conference where that has been done before. So I'm really looking forward to you know, seeing that in action.
And it's truly interactive, right, Timur? I mean, I think the whole point is that there'll be moderation both on the online and the in-person, so that anyone online can feel like they're asking questions in real time. And then we've done our best to incorporate things like Discord to keep that interactivity and networking going. But also, you'll see now in a few minutes when Ralph takes us through Gather, there's even more ways to network and be involved and feel like you're kind of present, right? I mean, that was a big part of it. I wanted to give another shout out now to Josh. Josh is our chair of our workshops this year. And it's also important to note that the workshops for ADC are all online. They happen the Friday of next week. So the in-person hybrid online conference is November 15th and 16th, Monday, Tuesday. And then on Friday of that week, on the 19th of November, is the online workshops. And the online workshops are being presented in participation and collaboration with the audio programmer. So if you head over to audio.dev and look at the workshops, you'll see that. And Josh, you want to say any awesome words about the great work you did there? I mean, killer workshops this year.
Yeah, once again, it's just been a privilege working with the ADC team this year. And what's been amazing is that Timur and I have been working with ADC for quite a while, actually. And when we started, it was really a 3 or 4 person team, and it's amazing to see how this has grown into something that has become that has expanded a lot into this hybrid experience. And I think that for anybody that comes to the conference, whether in person or online, I think you'll see that there's an extra added polish and an extra added experience that maybe has not been there in years past, and that's very much a testament to the work that the team has done. So now we have I think about 10 or 11 people that are actually part of the ADC team working on all kinds of bits, from sponsorship to the amazing experience that Ralph is going to be showing you in Gather, to the website, to our code of conduct team, and even more. So it's great to be part of this conference, and proud that this thing that we started just a couple of years ago as a simple YouTube channel has grown into something that now we have a partnership with the Audio Developer Conference. And I'm really excited to show you maybe a little bit later what workshops we're actually going to be presenting and the people we're actually collaborating with for this. So I'll hand it over to you, Ralph, to take things away.
Yeah. Well, I'll just say one last thing about the conference and the sponsorships. Just say, you mentioned the team, but the sponsors were just amazing this year. I have to say they really stepped up. The whole conference is being made possible by their generous support. It's really just amazing how many sponsors stepped up this year. So we really feel the love. I believe almost all the sponsors in some form or another will be there in person, which is also just amazing, right? So you get that as well. And you mentioned the team level, but just like you said, the number of volunteers that are stepping up also for online, in person, helping us moderate, code of conduct. I mean, I think all in, that team is probably close to 50, 60 people all in with the volunteers, and it's just amazing. So that's been great. Just a quick word about the workshops that we were just talking about with the audio programmer. Typically at prior ADCs, you would have to pay for the workshops or pay an additional fee to your ticket. What I find is unique this year is we decided to make workshops part of your ticket. So there is no additional charge for workshops this year. So even if you come in and do an online only ticket as a student, it's £35, very low fee. And that includes all of the workshops. So I think that's super exciting this year, and hopefully opens up just the accessibility to those workshops to people that may have not looked at them in the past because thought they were too expensive. So I'd like to continue a lot of that tradition with workshops going forward. So it's just great stuff. So enough of a plug there on the conference. If you want to check it out, it's audio.dev. I think you're right. Let's hand it over to Ralph as our head of the design mind, the person behind the green curtain. Take us there.
Yeah, so this is the Gather Space, and it's a virtual venue, and it's kind of configured like a little video game where you use your ASDW keys to wander around, or your arrow keys, and you could just wander around, and you have a little avatar, which you could totally customize and build. And when I made my avatar, I forgot the H. I was going in the fast, and I stuck with it. I'm Ralph online over here. So this is me, and you can see Bobby here, and he shows up. The interesting thing is that when we walk away, you'll see the video fades away. And as I get closer, he pops in. And if our microphones were on, we would be able to have a conversation there. And anybody could kind of walk by each other and to start talking. And it's really builds for interactive experience. Some of the, this is the where you'll land. This is the help desk, and we're going to put in some information in here. But you'll see that there's some areas where there's little carpets and tables, and these would be private spaces where we'll be able to get in, and only the people that fit on this private space can have the conversation, and everyone else outside will not hear your discussion. But let me show you the expo hall, because this is kind of interesting. So this is where our sponsors are going to have their booths, and you'll be able to walk up to any of these kiosks, and you will be able to, let me see if I could do one. I think there's one right here. Yeah, if you hit the X button, you'll see a video come in, and you'll be able to hit play and interact with the items that are within the booth. If we come over to this booth, I believe that we have the job board, so you'll be able to see any kind of job postings that the publish or that the sponsors are using here. We can keep walking through, and you'll see that every one of these booths is customized. They did a really good job putting together some of their products and product information. Let's get over to the JUCE booth just because it's a lot of fun. It's down over here. This is still a work in progress, so we're still building this out. But there's a lot of interactivity and a lot of areas that you can kind of wander around through in here. I want to show you a couple of things. So let's go all the way across the conference hall. So you kind of have to walk your way around, and you'll see that we have track rooms right here. And these are the track rooms where the talks will happen. So you'll go inside of one of these, and you will find yourself in a space where you're going to come up and take a chair, and you'll sit down, and it's not linked right now, but you would hit the X button, and you would see the Zoom talk. And so this is where you would sit and along with all your peers. And this is the largest space that we have. Let me go up and show you another smaller space. So this is track 2.
And I want to just mention, I have to say, like, it's hard to follow Ralph around, but one of the cool features about this is you can actually locate someone. Just you can see everyone that's online, and you can search for folks and see where they are. And then what I did was I just right-clicked on Ralph's name, and I just said locate him on the map or follow him, and I can just kind of quickly find where Ralph was. So you can see how quick Ralph is running through this, but you can find people pretty quick, and you can also see that, like, networking and speaking to people, meeting people. This is really what the big thing is about Gather, that you can have these like nice conversations with other attendees.
Right. Yeah. So there's be a lot of fun. I think it'll be a really good online experience that people will have. And we built in some fast travel, so that way you don't want to wander around. You just go right to these fast travel pads, and it'll jump you right to the spot. One last thing I'm going to show you that's a lot of fun. Is that the actual physical space at CodeNode has something called a space bar. And so we decided to keep that space bar and put it inside the virtual. And it's kind of a hangout space where people will be able to kind of socialize. And so these areas, again, will be private areas for the people that could fit on these tables. But if you're standing just out in the open space, anyone within earshot can hear you. But I want to show you the Cloud Lounge because this is kind of exciting. And it's this little blue arrow that hits right here. And it will take me up to the roof. And we have a rooftop patio up here. And we have a bunch of video games that are up here. We have a little park area, and we have poker tables.
Hey, Ralph, maybe it's worth mentioning that, these are a lot of kind of fun ways to socialize with other folks. But
Yeah.
you mentioned the video games. There actually is going to be something called the, what did it call it? The ADC Quiz Hunt, I think is what it was called. Is that right?
Yes.
ADC Quiz Hunt is a game that's only going to be inside of this Gather environment for ADC 21. And there's going to be some pretty awesome prizes. So there'll be a leaderboard, and basically you'll be hunting for clues and then gathering those clues, submitting them. And in that real-time leaderboard, you'll see who's in the lead. And this year, the prizes are just absolutely nuts. Those same generous sponsors, basically ponied up a number of hardware and software prizes. So very excited about that.
Yeah. The Cloud Lounge is put together by Pace Anti-Piracy and the iLog Cloud. So thanks to the team for putting this together.
Wait, is this a dance floor? Oh my goodness.
That's a dance floor. Oh, you dance by hitting the X. No, it's a Z. Z to the Z. There you go.
Ralph, you want to dance with me? Come on.
Yeah. I'm dancing. I need to actually dance on the dance floor, I think. There you go.
There you go. Solid.
Done. And there's piano. So if you see a piano, you can walk up to it and interact with it, and it will load the piano player in here, and this will actually play. And it's a cooperative piano. So Bobby's playing and I'm playing at the same time. So that's exciting. Let's see, what else do we have up here? But anyways, it's just a lot of fun. It's a good time to socialize in a virtual venue where it's really difficult to do that, because otherwise you're just clicking Zoom links and just going through watching videos. So this lets you be interactive. You can talk to your peers and ask what you think about, whatever you do at normal conferences. So this is really good. Yeah, if we cut across over here, you could see the London skyline, which is kind of cool. So anyway, is there any questions or anything like that?
We don't seem to have any questions in the chat, but I thought that maybe this would be a good moment just to talk a little bit more about just the general overview of ADC for people who may not be familiar. What is the conference about? Also, just in terms of the online experience, how would people tune in, and what does that schedule look like? Would they be able to ask questions live? Things like that. So I'm sure Bobby has a lot to speak about on that.
Yeah, I mean, it's a great point that, some folks maybe have not heard of the conference in the past. It's in its 7th year. So it is an event that is all about audio development technologies, and it can range pretty much on any topic. So it could be from audio DSP, processing, game audio, embedded systems. There's just a little bit of everything. And I hope if you get a moment, check out the, like I said, the schedule that Teamer had put together. There's just talks that kind of touch every aspect of audio tech, audio technologies. So getting into how the schedule was put together this year, because we wanted to go back in person, but we wanted to create a schedule that also made sense for other territories like the Americas and Asia Pacific, where these London-based kind of conference times don't really work out for everyone, because they kind of start kicking off around, say, 2 a.m. in the California time zone. So what we did this year was the conference does run on a London time type conference, so like your 8 to 6 o'clock type style. But there is a number of rebroadcasts that occur with the morning sessions that occur into the evening. And that sort of helps our America's attendees feel like they're more part of it, but also get to attend and ask questions, but also get to view them in sort of watch party style with other attendees from that same time zone or in other parts of the world in those same virtual track rooms that Ralph was just showing you. So that's there. There's also the ability to essentially see a vault of all the recordings of the talks that have happened so far. So you can essentially watch talks on demand. And I believe the way the technology is set up with the conference this year, pretty much within an hour, a live talk that just happened would get uploaded into that vault. And so that just provides yet another way to have attendees all around the world feel like they can access the materials while the conference is going on. The Gather environment that you just saw is live the entire time. So that Gather virtual experience opens up the evening before or the day before on Sunday of the conference. It kind of shuts down after that second day of the conference, but then opens back up again for the workshops. So that same interactive environment is also there during the workshops. And then the Discord server will be up the entirety of the conference. So that also starts up, I believe, Thursday of this week and provides yet another way to interact. So I guess the thinking this year as we designed the conference was, how do we make it as inclusive as possible for attendees that just can't make it in person in London? Or let's say you are in London and you're still not feeling a little too sure about the whole COVID situation and maybe online made more sense. This is yet another way to interact. That was a great question and a lot of stuff I said. So
yeah, I should actually add that I think the vast majority of talks are actually going to be rebroadcast. So if you live in a very different time zone, like you don't have to worry about missing out on anything. So I think it's really a great idea that you can either basically, if you purchase a ticket, you can either view the talks live or you can view the replays together with other people, or you can just view them in your own time by accessing this vault. So it's really just kind of a very, very flexible way to be part of it. So I think that's really exciting. That again, we haven't quite done it like this before. So I'm really excited how it's going to be in the end. I think it's going to be great.
Yeah, it is pretty exciting. And yeah, we haven't done this before, so it'll be interesting. And I really hope that people participate and interact. And that social connectivity is something that's unique to these conferences that people should really take advantage of.
Yeah, and just a reminder that that one of the tracks of the conference will be broadcast live via the JUCE YouTube page. So make sure you subscribe to that if you're not already subscribed. And the rest of the conference talks will be rolled out over time for people who haven't purchased a conference ticket. But if you want access to all those talks all at once or as they happen, be sure to get yourself a virtual ticket. It's not that expensive, and it provides great value opportunities for jobs if you're looking for those, opportunities to meet other audio developers. So it really is a great return on investment for people that are looking to possibly come out.
That's a really good point, Josh. Yeah, it's of course the talks are such a big part of it, but the networking, if you're looking for just for meeting more people in this space, I mean, this is such a great community. It provides such a wonderful opportunity to interact with others attending, whether it be online, in person, on Discord, you name it. You mentioned the jobs. The jobs are a big part of it. All of the sponsors have openings that they want to fill. So they are all there actively recruiting, and we will help them out by posting a number of those job adverts in different places throughout the conference. Even keep an eye on audio.dev website. There'll be a new tab that opens up with the jobs when the conference opens as well. So yeah, there's just a lot of excitement in that space. You mentioned the stream to YouTube. That's right. Like I keep forgetting that's a good part of it. If you can't, attend the conference anyway, shape or form, just know that if you subscribe to the channel and go over to the JUCE YouTube site, you'll see that not only are previous talks from the last 6 audio dev conferences posted on that channel, but that's also where we'll host the live stream of one of the main tracks for November 15th and November 16th.
Yeah, great. And was there anything else you want to mention? If not, I'll talk a little bit about the workshops that we're doing as well.
Yeah, no, I would say I would really encourage anyone listening, if you have questions, we'd love to answer them. And if you have any questions even about virtual conference spaces and kind of what's been built out, we have a lot of experience now in this space. Last year, we used the Remo virtual conference platform. This year, we moved over to Gather, and is still learning as we go, and really excited by the amount of interactivity we can offer there.
Yeah, absolutely. And if you're looking to purchase a ticket, you can do that on eventbrite.com, and I'll put the link to that in the chat, and just search for Audio Developer Conference, and you can purchase the tickets. There are discounted tickets as well for indie developers. So if you have a smaller company, or if you're studying, whether you're studying in high school or at university, there's discounted tickets that are appropriately priced for those as well.
I should also mention probably that if you actually do want to attend in person, because you are in London or you can get to London, there is still also the opportunity to purchase in-person tickets, and you can be part of the in-person experience, and we will have a very good crowd there as well. So just want to mention that too.
Yeah, absolutely. Ralph, Josh, Teamer, myself will all be there. And there is also some fantastic pricing on those in-person tickets for academics. So if you're a student or academic, it makes a lot of sense.
So the in-person venue is going to be Code Note, which is the same as ADC 17 and ADC 18. So some of you maybe have been there, you will recognize it. They're back in business and we're going to be back there. So that's going to be really exciting.
Yeah.
Do you want to mention about, there's also another reason to go to the in-person, the perks of, there are 2 events. There are actually a few that are very specific to the in-person. There is a women in audio reception that's very important to us, and that's coming back this year for the in-person. So very excited by that. And if you've been following us on social, you'll see some of those schedules, but it's also on the audio.dev schedule tab. There's also the open mic night and quiz night. Teamer, do you want to plug any of those?
Yeah, so I can plug the open mic night because I'll be hosting it, as I have done in previous years on multiple occasions. It's basically 5-minute lightning talks, except they don't have to be actual talks. They can also be musical performances or stand-up comedy gigs or anything fun and informal that you want to share with everyone. You can get like basically 5 minutes on stage, do whatever you want. You can sign up for that if you go to audio.dev/schedule. And you find the open mic night. There's going to be a link there to a Google form where you need to go to sign up. And there's going to be prizes for the best performances there. So I think that's going to be really, really exciting. So if you are there in person, you can sign up for that.
Teamer, Avid did ask us if we would plug their top prize for us. So do you want to do that or mention that?
Sure. So if you actually win the open mic night, which means you're going to have the best contribution as voted by the audience by a method that I have not yet determined, then you can win an Avid Carbon HDX DSP accelerated audio interface, which is worth quite a lot of money. So it's a really cool piece of hardware. So
yeah, they're including the software and their plug-in packs and everything. I think it's multi-thousands of worth of hardware software there, so that someone's going to walk away really happy. And then we have a lot of other prizes too. That's a generous gift and prize from Avid.
Great. Cool. Shall I talk about the workshops a little bit?
No, that'd be great, Josh. Yeah.
Cool. I'll share my screen. So we'll do this. There we go. And here we are. So we're currently on the audio.dev site. So that's a great place to go if you want to find out more information on where to purchase tickets, find out the schedule, and just find out more about the sponsors and what's happening in general. And here we're proud to be doing the workshops in collaboration with ADC. And we have some really great people who are going to actually be producing these workshops, and I'm very proud of them, and I'll go through them a little bit individually. So Getting Max Out of Gen is by Isabel Kaprisky, who is actually an engineer for Cycling 74. And so she'll be speaking about that. And that'll be a great workshop for people that maybe have a lot of experience with developing in MaxMSP, but are looking for ways to get that out into a JUCE project or onto a Raspberry Pi or other ways. So the second workshop is Introduction to CI, which stands for Continuous Integration, set up in the cloud. And that is by Akash Murthy, who actually works here at the Audio Programmer as one of our developers, and he's a fantastic developer, and he's going to be talking a little bit about continuous integration, and that's going to be another great talk for people who have their own independent plugin companies that are looking to streamline their work process, and so he'll be speaking about that. Next workshop is building an analog screamer pedal, and that's given by Eric Tarr. So you heard in the talk by Landon about Eric Tarr. He is a legend in the DSP and plugin game, and he has been nice enough to join us to talk about how to make an analog screamer pedal. So if you're curious about analog modeling, come to this workshop. Then the next workshop is given by the Focusrite team, and they're going to be talking about testing. So this workshop is called Put It to the Test. It's a workshop that is talking about how to get started with testing your audio plugins and audio apps. So testing is a way that people are able to build their apps in a more robust type of way. And especially if you're going to be building an audio application that is going to need to stand the test of time and be distributed to a wide array of people. So that's given by the Focusrite team. So that's going to be an awesome workshop. Then the next one is a journey to screen reader accessibility, and that's given by the good people at Ableton. So there are these 4 people here, but we also have some others that are going to be joining for this workshop, and that's going to be an awesome one. So if you're curious about accessibility in audio, that is a great workshop to learn how to get started using the native APIs for Windows and Mac, and getting into that. Then we're proud to have the JUCE team back to talk to you about building your first audio plugin with JUCE. So I think there are a few people that would have more expertise about how to actually build an audio plugin with JUCE than the actual people that created the framework. So we're proud to have the JUCE team to give their time to talk about that. And the final workshop is how to turn your love of code into a decent living. So many people ask me all the time, how do you make money doing this thing? Well, there are a few people that would be able to talk about it better than somebody like Russ Hughes, who has been able to build several online businesses successfully. And he will be talking more about marketing your plugin, marketing your product, and how to actually make a living and make some money out of building audio plugins and apps. So yeah, it's great to be partnering with ADC for this, and I'm very proud of this strong program that we've been able to put together. And thank you to the people that have also generously offered their time to share with us. So thank you, and we hope that you're able to attend. If you haven't got a ticket, please get one.
Hey, Josh, that was a great overview. I appreciate that. There were a couple questions that came in. Maybe we can see if anyone has questions online. I saw that a question came up. Can attendees share their screen in the Gather interface for portfolio sharing purposes? And then yes. Ralph, I'll let you answer that one.
Yes, yes, there is a share ability within Gather, and yes, you can share, and the people around you will, just like when you see the video, they will see what's on your screen. Mm-hmm.
Awesome. Any other questions? So there was one asking about finding the answers to some questions from a talk from ADC 2020. I might have to link up with Jas offline to talk about that and see. So I know Andy, and I can see if we can get the answers to those for everybody. Cool. Anything else that we've missed? So we've talked about workshops, general overview, Gather, purchasing a ticket.
I think we covered all the main points. I mean, we just wanted to share today a sneak peek of that Gather interface because so much time went into creating it. Ralph has really led the charge there, along with other team members, Jim Roper and Lena Brzezinskis. And I just think that it's just an exciting space. And I hope that a lot of our attendees really take the time to meet other attendees, because I think that's a great way to, just informally meet, but like someone just asked, a way to share your portfolio and your information. I do believe with the Sched, we're using the Sched scheduler program to show our program this year, the schedule of the event, but it also, that becomes another area where attendees can upload a bio of themselves and information if they wish to share with other attendees. I think that's another way to also network.
Yeah.
Audio.dev, right? The website.
That's the website. Absolutely. Yeah. I always, in my talks with Andrew, who's the person who actually is, what's his official role? VP? Is he the VP of Pace? I think he's the VP. Yeah. Sorry if I've messed that up, but
he's the big guy. He's good.
Yeah, head honcho. And we've had discussions about ADC and where it is in the audio development community space. And I've compared it to like the Super Bowl. So it's almost like the Super Bowl or the World Cup of audio development community activities. So it's the place where everybody just gathers to exchange information, meet each other, and help expand their career. So hope you can join us next week, whether it's in person or virtually. Cool. I think we've sold
really
it.
really appreciate this opportunity. Thank you, Josh. Thank you, Teamer. This is a lot of fun. Landon, really appreciated your talk. I am a huge nut with vintage analog guitar pedals, and I've been working on modeling some stuff. I worked on a product called Digidesign 11. I was the head product manager and working on all the algorithms on the 11 box and those pedals and whatnot. And it's a topic dear to my heart. When anyone talks about distortion, I'm always all ears and want to learn more. So yeah, and I model in Max as well. So awesome stuff.
It's amazing. Awesome.
Good stuff. Cool.
Right.
I think it's a good time for us to wrap up.
Yeah. I think that sounds good.
Yeah. Before we sign off, just want to give a shout out again to the people supporting the Audio Programmer Meetup. So Focusrite, Sonics, and the JUCE team. Thank you for supporting and sponsoring the Audio Programmer Meetup. Once again, we are looking for people to present at the Audio Programmer Meetup. It's held every second Tuesday of the month. And you can submit your talk on the audioprogrammer.com/submit. Once again, you don't have to be an expert or a guru to submit. It could be your first university project. Or if you are a guru, we'd also invite you to come along and share with us. It's all about sharing and just networking with other people. And also be sure to join our Discord on the audioprogrammer.com/community. Great place to meet other people and connect. With that,
exactly. So we see you in 5 weeks' time on the 14th of December, which is the second Tuesday of December. And with that, thank you very much for listening, and see you next month. And hopefully see many of you at ADC, either virtually or on site, depending on what you prefer.
Yeah, cool. All right, I will end the stream now, and we will see you soon. Thank you so much for joining.
Bye.
Cheers. Bye, everybody.
Bye.
Cool. We are